In this problem, we have two budgets. We have a public expenditures budget and an initiatives budget. So first of all, let's call P equals the public expenditure, dollars in the public expenditure budget. So we'll do dollars into public expenditures budget, and we'll do let's just use I equals dollars into initiatives budget. So initiatives budget, and I think once it's referred to as grade school initiatives budget, and the other time it's local initiatives budget. Okay, so the constraints that we're given is the board is willing to pay at least half of what comes out of the initiatives budget from its public expenditures budget. So what comes out in terms of dollars into, from the public expenditures budget is at least, meaning greater than or equal to, half the initiatives budget. We also know that since the program is considered to be an initiative, the government mandates that at least $2,000 come from the local initiatives budget. So that means that the dollars from the local initiatives budget is at least, meaning greater than or equal to, $2,000. Both budgets are partially funded by federal emergency funding. For the public expenditures budget, the percentage is 55% and 23% for the grade school initiatives budget. In order to properly use emergency funding, the district would like to minimize the use of federal dollars. So we're minimizing the objective function, which is, we'll just call it O for objective function. It is 55% of the public expenditures budget plus 23% of the initiatives budget. So this is where this is all emergency funding here, and you want to make that emergency funding as small as possible. So let's relabel. Let's call this Y and call this X, so that we can easily enter this into our calculator. So we have Y greater than or equal to 1/2 X, and then we have X greater than or equal to 2,000. We don't really need to rewrite this one, but we'll just remind ourselves that this is Y and X. And now we'll graph both of them. So over here I've already graphed 0.5x, but x greater than or equal to 2,000 is a vertical line. So what this thing is roughly going to look like is something like this. And at 2,000 will be a vertical line shooting up. So that means there'll be one corner point. There'll be one corner point right here because this region, well, y is greater than or equal to 1/2 x, means we shade up here, but x greater than or equal to 2,000 means we actually shade in the opposite direction. So we actually shade over here. So that means this region here becomes the feasible region. Now in order to minimize, we're going to test the corner point, which is this guy right here, but we need to know what it is. So what we'll do is we'll graph it. We'll graph our window from 2,000 to 3,000, since really we don't want to look at anything below 2,000 on the x. Now we'll just go up to 3,000, y from 0 to 1,500 because we don't want negatives. When we graph it, it looks like this. So exactly what we had mentioned here is that we have a corner point which is located at this little guy here. So that's x equals 2,000. So all I need to do is figure out what the y value is when x is 2,000, and I do second calc value, and when I hit enter it tells me that x is 2,000, y is 1,000. So that means the initiatives is 2,000 and the public expenditures budget would be 1,000. So this is in fact okay, because if you look at it, the initiatives budget is greater than or equal to 2,000. Well, it's 2,000, so that's perfect. And P is at least half of this guy. In fact, it's exactly half of it. So that means that we should put $2,000 from the initiatives budget and $1,000 from the public expenditures budget. Now we could also test what the total dollar amount from emergency funding would be by plugging it back in here, but we're not really asked for that. We could figure out how much is going to come from emergency funding that way.